This video will be going over section 2.4, the last section in unit 2, and it is on modeling with trig functions, specifically sine and cosine. And really what we have here is just word problems. We touched on the word problems back in section 2.1 and kind of mentioned then that we couldn't solve for everything as far as the word problems go. But we'll see how to actually solve for those other parts, not just find the equation and plug in a number, but find something meaningful. And then another thing that we'll see from the first problem here, a lot of times when you're dealing with any type of data, you're going to be given data points like an x and y value. They might mean something. X could be like a month in the year, and then y could be representing like the number of pools being sold by a company in that month. Just thinking about something random, and you try to fit what kind of function it should have. All right, and I just have one here that will be represented by a trig function, which you'll be told specifically. And we'll do this one first, and then we'll look at the word problems. Right. So this one says, find a possible formula for the trigonometric function whose values are in the following table. Right. Now, we talked about finding trig functions before, and we talked about how there's a lot of them that are correct back in 2.1. When we're thinking about trig functions here, if the two trig functions are the same, if we plug in some number and get out the same number. Right? Their formulas can look different, but the function itself is the same. The way we would represent that is looking at the graph overlapping exactly. Right, so the reason why it says possible here is there's many answers to this question. Just like you had with the trig graphs, there's many answers. You want to find one of them. And I won't go through all the possibilities like I did mentioned in 2.1 because we went over that, but I'll write one answer and then talk about how, or remind you how your answer can be different based on what you choose. All right, but what I would do if I was doing this problem is not try to just look at this and figure out, what trig function should I use? What is all this stuff going to be? But actually plot some of the points out. Maybe you can even plot all the points out, see what's happening. All right, but I will go ahead and say, because we are told it is a trig function, sine or cosine function specifically, we've got y equals a sine of b times x minus c plus d. We've got our formulas for sine and cosine that it could be, just depending on which one we choose. All right, just reminding you, we are going to use one of these. We're not going to use both, just depending where we're going to use sine or cosine. But regardless of which one we use, we're going to have the same a, d, and b. And so once again, these are going to be the same for everyone. And then what's going to be different is the c value, the phase shift or the horizontal shift. And this differs depending on what you choose, which trig function you use. Right, so when we plot, we'll see which one we should use and pair it off with the appropriate trig function, but it's totally up to you which one you want to use. Right, but I'm going to start, like I said, by plotting these points just to get the shape. Right, so the x values that you'll see are in increments of 3, starting at 0, 3, 6, 9, 12, up to 18. You might find that you don't need to plot all of them to get a good picture, but if you do plot all of them, you'll at least know you're not missing anything. The y values that we're seeing pop up here are -1, -4, and 2. So that's all I'm really going to put on the y-axis is 2, -1, -4. And you can try to draw it scaled out pretty well, but as long as your numbers make sense, you know, -4 is below 1, -1, which is below 0, which is below 2, that sort of thing. That's really what you care about. All right, but now let's go ahead and plot everything. So when x is 0, y is -1. When x is 3, y goes down to -4. When x is 6, y is back up to -1. When x is 9, y is up to 2. When x is 12, y is back down to, oops, not 0, -1. No, I didn't want to erase that part, but that happened. Back down to -1 at 12. And then when x is 15, y is back down to -4. And then 18, y is back up to -1. I managed to make a little mark here that I didn't want to put. All right, so we plot our points. We get this shape, and we know it's a trig function. If you want to connect them, there's nothing wrong with doing that. It's going to connect in the curvy way. All right, so the graph looks like this. But from here, you should be able to figure out A, D, and B without too much trouble at this point, because this is the kind of stuff that we dealt with before. Just before, we were given the graph already. This time we formed the graph based on the points. All right, so the midline is definitely down here at -1. D is -1. Let's go ahead and put that in. A, the amplitude, remember that is how far we go from the midline to either the top or the bottom. And that is going to be 3, going from -1 to 2, or -1 down to -4. And remember, B is 2 pi over the period. It's not actually on the graph. You have to figure it out based on the period. And if you want to see the period here, since we don't have 2 peaks, you can use the 2 bottoms. That's what I would do. I always use the peaks or the bottoms to see. It's easiest for me. The period here to go from bottom to bottom, from 3 to 15, is 12. We got 2 pi over 12, which is the simplified to pi over 6. All right, so no matter which one you end up choosing, sine or cosine, positive or negative, you better have A, B, and D be these numbers. Okay. All right, now C just depends on what you choose, right? Remember back when we talked about trig graphs, I know it's been a few videos, but it's based on which point you choose. If you use the top, you use positive cosine. If you use the bottom, you use negative cosine. If you use the middle and going down, you use negative sine. If you use the middle and going up, use positive sine. And my hope was back then that you practiced all of them, but at least got good with one of them so you can do it here. All right, and I'm just going to use cosine since seeing the top is the easiest. Since the top right here, the peak occurs at x equals 9. Then we want to use c equals 9 with positive cosine. Right, so let's go ahead and just write that in, even though I wrote it over there. The peak is occurring at x equals 9. We use c equals 9 with positive cosine. All right, but once again, there are a lot of answers to this. You can use c equals 3 with negative cosine. You can use c equals 0 with negative sine. You can use c equals 6 with positive sine. You just pick the one that you're most comfortable with at this point. All right, but if we plug in our a, b, c, and d into the appropriate one, which is the positive cosine, we get y equals, excuse me, since it's positive cosine, we just have a, which is 3, cosine of b, which is pi over 6, parentheses, x minus c, which is 9, plus d, and d is -1, so we get -1. Excuse me. All right, but that is one possible answer. There are many, many answers here, which we talked about before and I just described. right? But that's just something that if you were to do things with real life data points and you saw this kind of shape, you know, I'm sure the numbers wouldn't work perfectly like they have to with our problems, because that's really the way this works. You would try to draw your curve, and then based on your curve, you would ask yourself, okay, what's the amplitude, what's the midline, and all that stuff. All right, but now we'll get back to the word problems. And one of the word problems that you saw in section 2.1 at the end dealt with temperature. We found out the formula for the temperature, and I had mentioned, it wasn't in any of the problems, but I had mentioned that you can just figure out the temperature at some time by plugging in the t value. So this one's going to read a little bit different. This one says outside temperature over a day can be modeled as a sinusoidal function. Now this wording in the homework, what this means is that it's a sine or cosine graph. It might be sine, it might be cosine, but what we talked about, this is really referring to the shape. Sinusoidal means it has this wavy pattern. It can be sine or cosine. So suppose you know the temperature varies between 71 and 89 degrees during the day. All right, so what it's saying is the high temperature at the top is 89, and the bottom or the low temperature is 71. And the average daily temperature first occurs at 8 a.m. So the average, which you can figure out by figuring out the average of the top and bottom, add the two numbers together and divide by 2. 89 plus 71 is 160. 160 divided by 2 is 80. And this occurs first at 8 a.m. Right, now the reason they're telling you it first occurs then is because if you just kind of look at this graph here, from over one period between 3 and 15, you'll see the average occurs twice. Anytime you go through a period of a trig function, your average is hit twice. The only numbers that are hit once are the top and the bottom. Right. And the question is, how many hours after midnight to 2 decimal places does the temperature first reach 76 degrees? All right, so once again, you're going to see this in this type of question, does it first reach? Because it's going to get to 76 twice. We want the first time. Right. So the goal, what you got to do here is we need to make an equation modeling the temperature. This is something we did back in 2.1, but we'll talk about it again. And then once we do that, then it's going to tell us to plug in 76 for the temperature and solve. All right, so I want to talk about, getting the formula again from this information very quickly. All right, if you kind of plot out, we got the 89, which is the top, 71, which is the bottom. Temperature on the y-axis. That'll represent our temperature. And then we've got the average, which is 80 right in the middle. And I'll give some x values here because we know that 0 is midnight and 24, that's how many hours are in a day. And this is telling us the average occurs at 8 a.m., which means we're going to hit 80 at t equals 8. Right? If it was 8 p.m., then we would use 20 because 8 plus 12. So 8 here, the average occurs at 8. Right, but let's go ahead and figure out some stuff. We're going to have one of the trig functions, either sine or cosine. It's gonna follow from the same formula up here. And we're trying to figure out what A, B, C, and D are. When we figure out C, which one do we use? Right. Our A is gonna be how high up we go from the average to the top. So A equals 9 from 80 to 89. The average is exactly what D is. So D is 80. And B is 2 pi over the period. And the period is talking about the number of hours in a day, which is 24. And 2 pi over 24 simplifies to pi over 12. Right, now C is dependent on this point. Since this point that we don't know when the top's happening, we don't know when the bottom's happening. All we know is when the average is first happening. This is telling us C equals 8. We've got to use that. Now, since it's at the average, we're either using sine or negative sine. Right, because that's what we use the average for. The top is cosine, the bottom is negative cosine. The average is sine or negative sine. Right. And now this is kind of one of the things where you have to use a little bit of intuition. If you think about what's happening at 8 a.m., is it going to get warmer or cooler during the day? That's what you want to ask yourself. And just pick a normal day. Don't pick a day with very weird weather. You know, think about the temperature in the summer. We start off kind of cool, even though it's still very warm here, but kind of cool in the morning, and then it goes up and up and up. So it's got to be increasing at 8 a.m. All right, so that's why we're going to use positive sign. The temperature is going to go up at 8 a.m. Right, we just have to assume that it's going to do that, but it's going to pick the correct one. I actually think, I'm pretty sure I edited the problems. I took the problem here before I edited it, but I'm pretty sure I edited the wording for you to make that more clear. It'll say it's the average daily temperature is at some point, but increasing or decreasing. Okay. All right, so we're going to use positive sign. We got our A, B, C, and D. Let's go ahead and plug in everything to make our formula for our temperature. And if you want to use specific letters like we did before, you can. If you just want to use Y and X, you can as well. We don't have to actually plug in the formula anywhere. So we're going to have Y equals, we're using positive sign, and we've got A, which is 9, times sine of B, which is pi over 12, times X minus C, which is 8, plus D, which is 80. Right. This is our temperature formula. X is the amount of hours after midnight, and Y is the temperature. So we've made our formula. This is exactly what we did in section 2.1 as well. We knew how to make the formula back then, but now we're going to answer the question, when does the temperature first reach 76 degrees? So if we want to figure out when it reaches 76 degrees, and remember, degrees here is temperature, not the angle. We're not using degree mode. We're going to use radian mode when we do anything in our calculator. When does it first reach 76 degrees? Well, what it's telling us is to plug in 76 for Y, solve for X. All right, so we'll go ahead and begin that. We plug in 76 for Y here. Now, if you want to, you can distribute the pi over 12 through, but I would just recommend leaving it alone. Now we're solving for x, right? This looks pretty messy compared to the equations that we were dealing with last section. But it's not really any worse, it's just that the inside kind of looks worse. We still want to get the trig function by itself. We want to get the sine part with all the stuff inside by itself. Right, so what we do is we subtract the 80 from each side. (76 minus 80 is -4. Yeah, -4 equals 9 times sine of pi over 12 times x minus 8. And then we would divide each side by 9 to get the sine part by itself. All right, I'll continue this in the open space over here. So we got -4 over 9 equals sine pi over 12 times x minus 8. Now just think about what we did last section. Once we got the sine part by itself, we did the sine inverse to get it to go away. So we're now going to do sine inverse of each side. And we get sine inverse of -4 over 9 equals the inside. And go ahead and type that in our calculator. What is sine inverse of -4 over 9? All right, make sure you're in radian mode, which I am. The degrees here is only for temperatures, not related to the angle. You got to be in radian mode. We get -0.4606. I'll round it to 4 spots. Okay. All right, now what you do from here to solve for x, you can actually, we'll see, and I'll be able to explain better why once we actually arrive to the answer, but you can just solve this right away. You don't need to figure out all the solutions, and I'll be able to explain that better once we have the answer. So just continue solving this for x. Right, one thing you want to think about is because we're actually finding when the first time it happens, we're only going to get one answer. We only need one answer, and we can ask ourselves after we get our answer, is that going to be the right one? So let's go ahead and solve for x. All right, so what I would do first here is multiply by 12 over pi, the reciprocal of that, to get the x minus 8 by itself, and -0.4604. We multiply it by 12 over pi, and then that becomes x minus 8 because the pi over 12 cancels out. Now multiply these two together. Okay, so we can multiply this by 12 divided by pi. And we get -1.7592. -1.7592. And that equals x minus 8, because all we did was multiply this out. And now to get x by itself, we add 8. And we get x equals, let's see here. We want to add 8 to this. We get x equals 6 point, how far do we have to round? 2 decimal places, 6.24 for our answer. All right, so our answer here, we get x equals 6.24. And one thing I want to mention here, like I said, we can solve this directly. We don't have to get a whole bunch of answers because it's only looking for the first one. If you go back and look at all those problems we did in section 2.3, you'll notice that when we got our first answer, we would have to form the second one. And always forming the second one, that was the bigger of the two numbers. Right, so when you find the first positive one, as we just found, the first positive answer, it's the one where you get directly. And we're talking about hours after midnight. Okay, but let me go ahead because I know that we did a lot in this problem, and I just want to write some markers here. So we did this first. And then we solved second. Right, but there's a reason why I make videos, and these are not intended for you to just look at the end. Right, but all the stuff with the graph over here is how we figured out the information. We made our equation. Then after we made our equation for the temperature, we set it equal to 76 because that's what we wanted to do. And we've just directly solved it from there. All right, but that is not something we could have done before section 2.3 because we did not know how to solve equations. All right, so the last one I have here, pretty much all the questions in this section mimic one of the 2.1 questions, word problems. It's just taking that extra step, being able to solve them. The one that I said we would offload until now is the Ferris wheel problem. All right, this is something that we could have started in 2.1, but that video was long enough as it is, and we didn't actually do that. All right, so we'll talk about this. This one, the reason why this pops up with trig stuff is a Ferris wheel moves in a circle pattern. It moves very literally. It's a circle. Anything that moves in a circle pattern, it's pretty much following the unit circle if you think about it. So that's why sine and cosine pop up. All right, so we have a few things here. We're told a Ferris wheel is 50 meters in diameter. Pretty much anytime you're working a math problem, anytime you see numbers, that's going to be important. And it's boarded from a platform that is 5 meters above the ground. All right, so I'm going to go ahead and just draw this sort of picture out. It'll help explain what some of our answers are here. So we got this platform that is 5 meters above the ground. Right, so that is the ground here, and there's our platform. And then we got a Ferris wheel that I'm gonna try to draw this pretty good circle. And it is 50 meters in diameter, which means from the bottom of the Ferris wheel to the top is 50 meters. The 6 o'clock position on the Ferris wheel is level with the loading platform, which is just saying this is where we get on at the bottom. Right, the 6 o'clock position of the clock is the bottom. And I guess you could make a really weird Ferris wheel where you didn't get on at the bottom. But one thing I'll go ahead and mention here, because we're going to be talking about this Ferris wheel going around as time goes on. Since this is where you get on, this is where t equals 0. All right, so we got that part drawn out now. Another piece of information, we are told the wheel completes 1 full revolution, so it goes all the way around in 4 minutes. Right. Right, so you're at the bottom at t equals 0, then it goes all the way around in 4 minutes, you're back at the bottom at t equals 4. So what this is actually telling you is the period is 4, because that's how long it takes to repeat. So I'm going to go ahead and just fill that in. The units are minutes, but I'm pretty sure the homework just wants the number. And then the last line, finally, the function h equals f of t gives you your height in meters above the ground t minutes after the wheel begins to turn. All right, so all this is saying is when we get down to part D, you can see it says the equation. We're going to use h and t because that's what it's telling us right here, not y and x. If you type in with this equation that you get with y and x instead of h and t, even though everything else is right, it will be marked wrong. Right, but the 3 questions here that we have before the equation would be what we use to help build up the equation. What is the amplitude? What is the equation? Not equations, equation of the midline. What is the period, which we already mentioned is 4. And then we're going to use that to make the equation. All right, so you want to think about the amplitude and the midline in relation to the Ferris wheel. The midline is going to be the middle of the Ferris wheel. All right, meaning if we go halfway up on the Ferris wheel right here, that's our height of the midline. All right, so it's not just halfway up from the ground to the very top because we're only going up and down or around, however you want to think about on the Ferris wheel. We're not concerned with the actual platform when we think about the midline. Same thing for the amplitude. You can kind of see the heights here. The bottom is at 5 meters above the ground. The top is at 55 meters above the ground. But the amplitude is just really the radius of the circle, because it's how far we're going up to the top or bottom of the Ferris wheel from the middle. And the amplitude, since it's half of the diameter, it's the radius, it is 25. The midline is just something you want to be careful about. It's really easy to make the mistake of just adding these 2 numbers, 50 and 5, and then dividing that by 2, because you think that's halfway up. But remember, the midline is halfway up on the Ferris wheel. So we're automatically above the 5, and then halfway up is 25 more. 5 plus 25. So they tell us to use h instead of y. We're going to have h equals 5 plus 25, which is 30. All right, we got to consider both parts here. We got to be above the platform, and we got to be halfway up on the Ferris wheel. Okay. Now, finally, the last part. To form our equation, you'll notice the amplitude is A, the midline is D, the period is related to B. I'm not going to write that in here because I don't want to cause any confusion. I'll write it below. But what you want to realize is where we're getting on is telling us what equation to use. Since we're getting on at the bottom, we know we're starting at the bottom. What we do is we use negative cosine because we're starting at the bottom, and c equals 0, because that's the time we're getting on. Okay, so we are using negative cosine because we know when the bottom happens, and we know it happens at t equals 0. All right, so let's go ahead and put this all together in our equation. We have y equals negative for cosine a cosine b is x minus c plus d. We have a from part A is 25. We have d from part B, the midline, is 30. We have b, which is 2 pi over the period. And we figured out the period is 4. 2 pi over 4 is pi over 2. And then lastly, we just discussed c should be 0, because we know when the bottom is happening, and that is at t equals 0. All right, but once again, I put the y and x here, but your final answer, which I'm going to write it in as, you got to use h and t. We got h equals negative a is 25 cosine b is pi over 2 t. Since I have c as 0, I don't have to include the parentheses, extra parentheses there, plus d, which is 30. And that is the equation for part D here. That is the equation of our Ferris wheel. Oftentimes I find that, the Ferris wheel equations come a little bit easier, because really, you can't imagine a Ferris wheel where you get on anywhere except the bottom. So it's always negative cosine. But one thing you can do to maybe check your answer, feel more confident in it, is graph this. Because if you do make a mistake, I would probably guarantee it's going to be between the amplitude and the midline. And if you graph this, you probably won't be starting in the right spot. You won't be starting at a height of 5. So let's go ahead and do that just to check. So we had negative 25 cosine of pi divided by 2 times t, but we have to use x in here, plus 30. For our window, our height is going between 5 and 55, so I'll just do 0 to 60 for y. And for x, that's representing the time. The time's going to go between 0 and 4, because that's the period. And somehow we already have 0 and 4. Y, we're going to go from 0 to 60. I'll make the scale 10 so there's not a lot of hash marks on the side. And then if you graph it, this thing is representing the height. Right? Remember, it's not going to actually make the circle shape. It's only telling you the height over time. So you start at the bottom of the Ferris wheel, then you're going up, 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 up. And then you start slowing down when you get to the top, because you're not rising as fast. Then you get to the top over here, and then you start going down the Ferris wheel. But if you calculate the value when you plug in the starting time of 0, you should get 5, and you do. It works out. You can also check the top height, because you know the top height should be 55, and it also should make sense that it'll be half our period. So at t equals 2, halfway from going all the way around, we should be at the top. If we plug in x equals 2, we also get 55, our maximum height. So it all works out. All right, so I just want to do 2 things with this equation. Neither of them is necessarily something you can't do, but especially the last part might seem a little tricky initially. All right, so this first one, it says, how high are you off the ground after 2 minutes? Now, we kind of talked about why this should be 55 already, but to actually verify, actually do the work, it's telling you to plug in t equals 2. Right, because it's asking us how high off are we off the ground after some time. And we get h equals negative 25 cosine pi over 2 times 2 plus 30. This is one that you can do by hand. I'm sure not all of the times you're given you'll be able to do by hand, so you can just do this in the calculator as well. But the 2 over 2 cancel. We get negative 25 cosine of pi plus 30. And cosine of pi, why we can do this by hand is that's the negative x-axis, the angle of pi. So cosine is negative of pi is negative 1. 25 times negative 1 is 25 plus 30 is 55. But we pretty much showed it in the calculator as well by plugging it in. Now part F seems a little more challenging because of what it's asking. It's sort of like the previous problem where we want to set our equation equal to something and solve it, but it's not as direct. So this one says, how long does the Ferris wheel spin above a height of 35 meters above the ground? All right, so I'm going to go back to the graph to explain what it's asking. This thing is representing our height. These hash marks are every 10, I believe, how I made it. Let's go back to the window. Every 10, starting at 0. So this is a height of 0, 10, 20, 30, 40, 50, and so on. The 35 is right about here. So after some time, whatever this time value is, we're going to start to be above the height of 35. And then when we get back on this side, we're also going to drop below 35. So what it's asking us to do is to find our two solutions. Just like we did back in 2.3, we find our two solutions. Once we find those numbers, we'll subtract the two answers. All right, so let's go ahead and write that down. We want to find the two solutions when we set our equation for our height, which is from part D, equal to 35. And then once we find our two solutions, subtract them to get the answer. Okay. And this one looks a lot more like the problems we did in the last section because there's only some number times t inside. But since we do need both solutions this time, it's a good idea to remember how we did it last section. All right, we start by getting the cosine part by itself. Subtract our 30 from each side. We get 35 minus 30 is 5 equals negative 25 cosine of pi over 2 times t. We divide each side by that negative 25 to get the cosine by itself. And we got 5 over negative 25, negative 1/5, if you simplify that, equals cosine of pi over 2 times t. Just like in the last section, just like in the previous problem we did, once you got the trig function by itself, you do the inverse appropriately. We do cosine inverse this time of each side, and we get cosine inverse of negative 1/5 equals the inside over here, pi over 2. And let's type that in our calculator. Once again, we're in radians modes. You only use degree mode if you are told at some point. But pretty much any word problem that doesn't have a triangle with it, you're in radian mode. So yeah, cosine inverse of negative 1/5. And we get 1.772. Doesn't say how far to round it. It's probably 1 or 2 spots. We'll just do 2 spots. So I'm going to round 3. We got 1.772 equals pi over 2 t. Now I know we are thinking about the Ferris wheel problem, but one thing that we did when we solved these last section is, when we had to find our second answer, we asked the question, what quadrants is cosine negative in? then this is one of them. We have to find the other one. And cosine is negative in quadrant 2 and 3. Because it's the x value. X is negative in quadrants 2 and 3. We're going to draw our picture, just like I have every single time when we solve an equation. Make sure everything's kept track of. And the one we just got is in quadrant 2. Remember when we saw these equations last section, we did not solve for x or t right away. We had to get our two answers first. So this is our 1.772. And the answer in quadrant 3, we will figure out from our picture. Visually, it looks like this. So that's where our angle in quadrant 3 is going to work in. And the way we figure out that angle is using reference angles, because they have the same one. Right, so the same reference angle here. The reference angle we can figure out from the quadrant 2 angle, because it would be pi minus the quadrant 2 angle, 1.772. Let's see what that is. Pi minus 1.772. Oops. And we get 1.369, 1.37. Well, let's just go 4 spots. 1.3696. And the way we would compute our quadrant 3 angle, since it's beyond pi by that reference angle amount, we get pi plus 1.3696. And what does that give us? We get 4.511, rounded to 3 spots. Yeah, our quadrant 3 angle 4.511 equals pi over 2 times t. Now that we've gotten our angles for each, now we can solve for t by multiplying by the reciprocal for each one, multiplying by 2 over pi. Right, because we're trying to figure out actually how long we're spending. Now we're not trying to figure out the angles specifically. We want the t values. Solve each for t by multiplying by 2 over pi, the reciprocal. All right, so this first one here, we get t equals 1.772 times 2 over pi. See what that is. We get 1.128. And the second one, we got 4.511, which we multiply by 2 over pi to get rid of the pi over 2. And we get, I forgot my decimal point here. What is 4.511 times 2, oops, divided by pi, 2.872. Okay. So we look here and we see the first, this is telling us how long the Ferris wheel first takes to get to a height of 35. And this is how long it's the second time to get to a height of 35 meters. But like we wrote over here, we got our two answers. Now we subtract to get our final answer. And you definitely do the bigger one minus the smaller one, so your answer is positive. 2.872 minus 1.128. And we get 1.744. Right, so that is our final answer. The Ferris wheel spins about 1.744 minutes above a height of 35 meters. Right, but if you look at the graph, you can kind of make sense of that. Right, so let me just go ahead and plot y equals 35. You can see right here, the first time they intersect, it's a little bit past 1. Maybe that's that 1.128. And the second time they intersect right here, it's a little before 3. That must be that 2.872. So our numbers make sense. Everything looks good. Right. But ultimately, that is really the main questions in this section. We got some temperature questions. You got some Ferris wheel questions. Make sure you know how to find the formulas and then do the appropriate thing with the formula. Sometimes, like this one over here, you just have to solve for that first answer, and it's just, kind of plug it in and go. Sometimes it's like the second one down here where you have to find both answers. So there is a reason why we talked about solving trig equations, getting all those answers. You really got to make sure you're getting everything when you solve a trig equation.